Hi everyone, this is Shanthamathi K S, Assistant Professor of EC Department. So in this presentation, let us see about wireless channels, which is the Unit 1 on wireless communication. So the first topic in this unit is large-scale path loss. So first we'll see path. So what is meant by path? Yes, path is nothing but a way. So here, a radio signals travels from transmitted to the receiver in the wireless medium. So the way the radio signal takes, so that is called as the path. Okay, so in that path some losses may occur, that is the strength of the signal may gets reduced, right? So this is called as path loss. So in that path, how much the radio signal is lost is called as path loss. Large signal path loss means the distance between the transmitter and the receiver is more, which means few tens kilometer. It can be few tens kilometer or few hundreds kilometer, not few tens, few hundreds kilometer. Okay, so in that cases, for that distance, some signal strength may get varied. Okay, so this is called, that is the separation distance between the transmitter and the receiver will be more. So in that case, the path loss, we can call it as large scale path loss. Next is modes of propagation. So there are three modes of propagation: reflection, scattering and diffraction. Okay, before that, radio propagation model. So how these radio signals are transmitted between the sender and receiver. So it can take two paths. It can take two paths. One is line of sight and the other one is obstructed by buildings and mountains. Line of sight means there will not be any obstacles between the transmitter and receiver. So it can also call it as it is a direct path. Okay, obstructed by buildings, mountains and foliage means this radio signals may hit on the buildings or mountains or like that. Yeah, we'll see that reflection first. So reflection, you consider the radio signals are transmitted from the transmitter and this radio signal hit on any smooth surfaces, okay, like building, earth. So this radio signal is coming from the transmitter. It has some frequency and definitely it has some wavelength. So when this wavelength is compared to the size of that smooth surface is building, earth, as I said. Okay, so when this wavelength of the radio signal, it is very less when compared to the size of the obstacles, this radio signals will follow the reflection. Okay, so that is the radio signal is getting reflected back to the wireless medium. Okay, so this is called as reflection. Next we'll see that diffraction. So diffraction means it occurs when the radio signals transmitted from the transmitter and receiver is obstructed by the edges, which means buildings edge or mountains edge, any edge particles, any edge places. Okay, so in that edge place, when this is getting reflected, we can say that is called as diffraction path. And scattering. So scattering here means when the radio signals again from the transmitter, when it hits on the rough surface and reflected back to the wireless medium. So in the case, this case is called as scattering cases, right? Okay, so this is consider when you see this diagram, you can easily understand these three propagations. So this is a building. So these four rectangles are the buildings. Okay, so this yellow color denotes the transmitter. So from the transmitter, the signal is getting transmitted. So it is hitting this smooth surface and reflected back. So this is R, as we have written, it is a reflected, and it is hitting this black color dot, right? So either this can be your hard surface and from there it is going this and it is hitting on this edge of this building. So edge la patta again it is getting reflected to that receiver. So this is called as diffraction. So edges means diffraction, smooth surface means reflection and hard rough surface means scattering. Okay. So just we'll recall all these topics in the unit 1. So Brewster angle is the angle which no reflection occurs in the medium of origin, we can say. Fading channel. So first we have to know what is fading. So fading means rapid fluctuation of any signal strength. That is, the signal strength keeps on reducing as it is going far away from the transmitter. So for large scale, this fading we can call it as path loss. For medium scale, we can call it as shadowing, and for small scale, we can call it as multipath fading. Next is the link budget design. So a link budget is the sensitive way of computing the required transmitting power. So how means we connect the transmit power to the received signal to noise ratio. So in logarithmic form, that is in decibel form, we will be designing this link budget in two models. One is log distance path loss model and the other one is log normal shadowing model. So first we'll see log distance path loss model. So here the average received signal power decreases logarithmically with distance. So this path loss PL of this distance d, the small d indicates the distance between the transmitter and the receiver, that is proportional to d by d naught of n. So this d we know, the distance between your transmitter and receiver, and d naught is the reference distance, and this small n is the path loss component. So this path loss, so in the previous equation we can write in a decibel form like this. So that n value, n is a path loss exponent, right? So for based on each environment, this n values will be getting varied. For free space, for urban cell already shadowed, in building line of sight, in factories and in buildings, everything this n value is getting varied. Okay. And next is log normal shadowing. So this we know will be taking distribution here. So the path loss plus 0 mean Gaussian distribution random variable will be taking with that standard deviation. That is the only difference between log normal and log. Next is small scale fading. So small scale fading is the rapid fluctuation of the amplitude of a radio signal over a short period of time. And large scale fading means it is fading with a large coverage area for large amount of time, we can say. Multipath. So multipath means several paths, only we can say it as a multipath. So several delayed replicas of the signal arriving at the receiver from the same transmitter. Okay, so there will be a rapid fluctuation in amplitude with time. So this is called as fading, and this may result in poor signal quality, right? So when you consider this diagram, you can easily understand. So in the car, someone is talking and going, consider a mobile communication, right? So someone is using that mobile, so he is the receiver, and from the transmitting antenna, this is the base station, right? So from this base station transmitting antenna will be receiving that signal. So you see how many paths it takes to reach this receiver. So totally it is taking 4 paths. So one is the direct path, that is directly from transmitter it is reaching to that antenna in that mobile what you are using in the car. And the second path is this transmitted like this, and it reflected back from the building. And third path, it is transmitted and it is going this way, and it hits on that mountain and it gets reflected back. And the fourth path is it is getting reflected where the plane flying, right? So from there it is getting again reflected. So it takes 1, 2, 3, 4 paths to reach the receiver. This is your multipath propagation, we can say. So this is another example. So you consider this is the base station. From the base station, 2 signals are transmitting. One to mobile 1 and another to mobile 2. Right. So these are the mobile 1 and mobile 2 are the receivers. So this mobile 1 gets 1, 2, 3, 4 signals from the 4 path. One is your direct path, second one is this yellow color building, third one is this green color building's reflection, and fourth is reflected from that fourth building, right? And for this M2, that is mobile 2, we are receiving the signals in 2 paths. One is your direct path. This direct path is also called as line of sight path, and the other one is it is reflected by the building which is in red color and it's reaching the receiver. Okay, so this is your multiple channel, we can say. Multiple channel 1, multiple channel 2. For this mobile one, multiple channel 1, multiple channel 2, 3 and multiple channel 4 we have. Okay, so small scale fading, as I said earlier, the term fading is used to describe the rapid fluctuation of the amplitude of any radio signal over a short period of time or short distance. Okay, so this fading is caused by destructive interference. We can also call it as the multipath propagation. So the effects of fading. So what are the effects when fading occurs? Means there will be the rapid changes in signal strength over a small travel distance or time travel. This is what first point. And there will be frequency modulation will be random due to varying Doppler shifts or different multipath signals. And the third one is time dispersion caused by multipath propagation delays. Next we'll see factors influencing small scale fading. Multipath propagation. So multipath propagation, so the diagram what I've shown before. Okay, so multipath propagation, multiple channels will be there for reaching a signal from the transmitter to the receiver. Speed of the mobile. So speed of the mobile means speed of the mobile in the sense that is how fast or how slow the mobile is moving from one place to another. The next, speed of surrounding objects. Speed of surrounding objects in the sense, so consider a car. So we are moving in a certain speed, right? So in that car we are using that mobile, that is we are an ongoing call. So in that cases, when another car or any big truck, or it can be any vehicles, when it going fast or when it going slow, so when the receiving signal may be reflected from that vehicle also. So this surrounding objects speed also may influence its small scale fading, and obviously your bandwidth of that transmitted signal. Okay, next is Doppler shift. So we know what is Doppler shift. So consider the S is the source, that is your transmitter. So from the transmitter the signal is getting transmitted. So in the car only we are talking and going, that is ongoing call is there in the car. So when this receiver, so this car is the receiver and the CS is the transmitter. So when the receiver moves towards the arrival of the signal, so arrival of the signal is from, this is the transmitter. So when the receiver goes towards the transmitter side, there will be the Doppler shift. So that shift will be in the positive. So this FC plus FD we can write. Okay, that is Doppler frequency is FD. So another case, when the mobile is moving away from the direction of the arrival of the signal, means the Doppler shift will be in negative form. Next is the parameters of mobile multipath channels. So the 3 parameters are there. First one is mean excess delay, second one is RMS excess delay, and the third one is excess delay spread. So mean excess delay, we'll see the first. Okay, so next, time dispersion, we have 3: coherence bandwidth, Doppler spread and coherence time. So parameters of mobile multipath channel. First is the mean excess delay, and this is denoted by tau bar. So tau in the sense delay, tau bar is mean excess delay. So mean excess delay means this is the first moment of the power delay profile. First moment of the